Hello everyone, welcome to my brand new series on chemical equilibrium. Have you ever wondered why certain reactions stop halfway or how we can shift them to give more product? If you have, not to worry, you are in the right place. Today, we'll be looking at chemical equilibrium. And under them, we'll look at what is chemical equilibrium, what is reversible reaction, we'll look at the concept of dynamic equilibrium, and we'll look at a real-life example that help you understand the concept of chemical equilibrium properly. Now, first, if we have a reaction A and B, and we denote it with two arrows to form C and D, this implies that these two arrows says is a reversible reaction, meaning one is going in the forward direction while the other is going in the reverse direction or the backward direction. That is what a reversible reaction is all about, a reaction that can proceed in both directions. All right, so what is a chemical equilibrium? Chemical equilibrium simply is just a situation whereby the rate of the forward reaction becomes equal to the rate of the backward reaction. That is chemical equilibrium. When the rate of the forward reaction becomes equal to the rate of backward reaction, we have what we call a chemical equilibrium. For in this equation, we have that A reacts with B to form C and D. Now, when the reaction begins immediately, A will react with B quickly to form C and D. But over time, C will start reacting and then it will start forming what? A and B gradually. It will build up to a point whereby the rate at which C and D react to form A and B will not be equal to the rate at which A and B react to form what? C and D. At that point, we say dynamic equilibrium has what? Been established. Let me explain now with a graph. Maybe you want to understand better. If we have a graph where this is our rate of reaction and here is time in seconds. Now, if this is our reactants and they begin from here, started reacting, so the rate will be decreasing because the concentration of the reactant will what? Be decreasing. You get to a point and the rate remains steady. Simply because the product started reacting gradually because the concentration was less. As the concentration of the product built up from what the reaction of A and B to form C and D, the rate will increase. It will keep increasing until you get to a point also they meet and the rate becomes the same. At this point where the rate is the same is what we call equilibrium position. Equilibrium position. And this is our what? Reactant. Why this is our what? Product. Now, if we want to explain that in terms of concentration using graph, if we have also a graph of concentration against time, concentration against time in seconds, and here is concentration in mole per dm cube. Now, if our reactants are here, from the beginning the reactants will start reacting because the concentration is high. So it will start reaction and then be depleting. As the concentration reduces, it will go down. It will get to a point whereby the concentration will become stable. Now, the product with low concentration from the beginning will start building. They will build. They will build. They will come to a point whereby their concentration also remain what? Stable. This point whereby their concentration becomes stable is what we refer to as the equilibrium position. Equilibrium position. Here is our reactant and here is our product. Now, what does it mean? At equilibrium, reaction is actually still taking place. The reaction has not ended. It is still taking place. But because the concentration of both the reactants and the product are stable, you will not be able to see the reaction exhibit as product because all the products and reactants have attain a balance in the system, and that is what a dynamic equilibrium is what all about. All right, now key things you must know when a system is in equilibrium. One, the system must be closed. That means nothing is coming in and nothing is going out. It must be of constant concentration. For it to remain in equilibrium, it must be of constant concentration. And lastly, it must be what? Reversible. Now, let me give you a real life example. If we go to a mall that already has 50 people. 50 people. A mall with 50 people inside. And then every time 10 people comes out, 10 people come in. You agree with me that the number of people in the mall have not changed, but there is still movement in and out of the mall, but the number inside the mall has not changed. That is what dynamic equilibrium is all about. All right, what did we learn? We learned that chemical equilibrium is when the rate of forward reaction is equal to what? The rate of backward reaction. That a reversible reaction is one that proceeds in both directions. Dynamic equilibrium is established whereby the rate at which reactants convert to product is equal to the rate at which product converts to what? Reactant. And we say equilibrium can only be established when the system is closed, the concentration is constant, and the system is what? Reversible. If you like this introduction to chemical equilibrium, give me a like, share, and comment with your question or contribution. And do not forget to follow so that you will learn when I post a new video, especially in the next class when I'll be doing equilibrium constant. See you in the next class.